Hi there, and welcome to another Popetti Math YouTube video tutorial, where today I'm going to be teaching you, yes you, Algebra 1. And in this video, we are going to be looking at our final exercise on linear regression. Now, if you remember from exercises number 1 and 2, linear regression is very useful to take a set of data, bivariate data, meaning variables with number data that we don't know if it has a pattern between it or not, and finding a pattern or a line of best fit that matches the set of data. So what we did in exercises numbers 1 and 2 was we created this linear regression equation, and we even predicted in the previous exercise a missing value that we did not have. So we're going to look at exercise number 3 now and do some similar stuff and then add on to it a little bit more. So in exercise number 3, it says the information contained in the table below represents the real estate value for a newly built home in a certain area of Long Island over the first 5 years. Create a linear regression equation to model the data. Round all values to the nearest dollar. So we're going to be rounding to the nearest dollar, not the nearest cent. And we're going to be putting this in our first list and this in our second list. So we could go ahead and we could take out our graphing calculators. We're going to be using our stat button on here. We're going to be editing our lists. So go ahead and click enter to edit lists. And then we're going to clear out any information we have. And again, highlight the list, click clear, then enter. We're going to do that for all of our lists to make sure we're starting fresh and we don't have any values left over. Okay, so in list 1, we're going to put 0 through 5. So we'll put 0 at the time the house was first built, 1 year after the house was built, 2 years, 3 years, 4, and finally 5. Once we get those values in our list 1, now we're going to be putting the value of the home in list 2, and we're going to have 510,000. Then we'll have 505,000, 495,000, 491,000. We have 483,000. And finally, we have 479,000. So here are our values in list 2. The value of the home, it looks like it's decreasing. But now in our linear regression equation, we're going to be able to see by what pattern is it decreasing exactly by. So again, we want to go to stat and then over to calc. Once we get there, we want to go down to linear regression, option number 4, and click enter. All of our lists should be in place as shown there, and we're going to click on calculate next. And this is our equation of y equals ax plus b. So we're going to round all values to the nearest dollar again. So we'll have y equals negative 6,429, negative 6,429x. And then our y-intercept is 509,905 plus 509,905. Rounded both of those up because of the decimal following. So now that we have this equation, we want to explain what the slope and y-intercept mean in the context of the situation. So again, our slope is our change in y over our change in x, and our y units are the value, so that's going to be dollars. And our x units are years. So this is going to be the dollars per year. So this is going to be a decrease. So the slope represents a decrease because it's negative of $6,429 per year. And again, we got the units there, dollars per year, because slope is y over x, and this is our y column, and this is our x column. So value over year, dollars per year. So our y-intercept, on the other hand, is going to be this number, 509,000. So the y-intercept represents the initial value, our y-intercept always represents the beginning value, the starting value, the initial value of the home when it was built. And that value is actually very close to the given value in the table. It's only about $95 off of $510,000. So this line of best fit that goes through 509,905 is pretty accurate with the actual data value that's given to us, 0 and 510,000. So again, the y-intercept will represent the initial value of the home when it was built. Now finally, in part C, it says the contractor invested $440,000 building the home. At this rate, how many years does the contractor have to sell the home from the time it was built before she starts losing money on the investment? So what we might want to do here is we want to see how many years it's going to take for the value to be $440,000. So that's going to be our Y value. So we'll substitute 440,000 in for Y into this equation. And we will keep everything exactly the same, negative 6,429x plus 509,905. We're going to solve this couple-step equation right here. I think it's going to be 2 steps because first thing we're going to do is we're going to subtract the 509,905 from each side. We're going to be left with negative 6,429x is equal to, let's go to our calculator. We'll clear out anything here. And we'll have 440,000 minus 509,905. We'll get negative 69,905. And we'll have to divide that by negative 6,429 to get an x value. So now let's divide this number by negative 6,429, and I just need to change that to a negative sign. There we go. And we're going to get 10.87. So x is going to be about 10.87 years. So how many years does the contractor have to sell the home from the time it was built before she starts losing money? So be careful because at 10 years, she's still above the value of the home because at 10 years, it's not going to be below 440,000. At 10.87 years, it will be. So at the 11th year will be the first year that she starts losing money. So we want to be careful and always go back to reading the question, making sure that we're answering what's being asked. And it's going to be 11 years before she starts losing money on the home. And again, if we want to go and we want to check that out in our calculator, we could go to y equals and we could type in that equation, negative 6,429x and plus 509,905. And when we go to our table there, we could see that at the 10th year, the value is still above $440,000, but it's at that 11th year that it dips below the $440,000. So again, there's a couple ways that you could do this using the table in your calculator or by solving it algebraically. So this shows that at the 11th year, it's going to be the first year that it's under $440,000. So either way. So if this video was helpful in order to create a linear equation to model a set of data, a table of data, and then explaining what slope and y-intercept meant in the context of a situation, and then also answering one step further question in this part C right here, then give this video a thumbs up to let me know that this video was helpful to you. You're now ready for lesson number 6 in our chapter 12 on statistics.